Hi people, welcome to part B of my video series on discovering novel strategies to defeat COVID-19 through knowledge graphs. In part A, I gave you an introduction as to how knowledge graphs can be helpful in tackling COVID-19, how knowledge graphs can help by providing insights into relationships between seemingly disconnected entities and thus can indirectly help scientists and researchers in the development of new drugs or vaccines or even other forms of therapies for defeating COVID-19. Towards the end of the last video, towards the end of the video in part A, I had a question that if knowledge graphs are so useful, is it possible that 6 months into the COVID crisis, no knowledge graphs have been made? And I'll turn to that question today more in greater detail. I'll discuss the entire thing more extensively. So in part B, I'll have a review of the existing knowledge graphs and I'll discuss the limitations of the existing knowledge graphs. So the question was 6 months into the COVID-19 crisis, do no knowledge graphs exist? The answer is, of course they do. So if you just Google for COVID-19 knowledge graphs, as always, you will see a large number of links out there. And if you were to go through a good number of them, at least the ones which occur first, and if you were to do investigation by yourself, I'm pretty sure that the ones which you like most will be these. So I did spend a good deal of time investigating the knowledge graphs which are out there. I tried each one of them and I found these as the best ones. If you Google about them and you come across something which is better than this and which also covers the functionalities which I'm going to discuss next and also addresses the limitations, you let me know. This will save time for me as well. I can then focus on other things. So the COVID graphs which I found most useful, the COVID-19 knowledge graphs which I found most useful were the following: IBM COVID-19 graph, COVID Graph Explorer, Amazon COVID-19 knowledge graph, Biomedical Knowledge Miner, BioGricken COVID, which was another COVID-19 knowledge graph. And these were actually mind-boggling initiatives. These COVID graphs had information on drugs, on genes, on proteins, and many of them showed how this information can be connected and how these insights can be used to help in the development of drugs and other solutions. However, as I mentioned earlier, I found certain limitations with these knowledge graphs, and it is these limitations which actually motivate the entire project that I'm working on. So there are limitations of two kinds. There are limitations which have to do with all the knowledge graphs which I've seen. Those are general limitations. One of the limitations is that these knowledge graphs, whichever one of them you choose, they actually focus on a very small subset of entities. And that subset is restricted to genes, drugs, chemicals. While those entities are nevertheless central to discovery of treatments, it is important for us to realize that there are thousands, literally thousands, and maybe lakhs of other entities which are no less important. When you actually Google for research papers on COVID-19, you find that people actually have done research related to different things. So there is research out there on the impact of environmental factors, on the impact of say different gases in atmosphere on the spread of COVID-19. There is research on how light or radiation in certain wavelengths can help reduce the lethality of COVID-19. There is research on how temperature affects COVID-19, not that what we were believing earlier, with higher temperatures, the infections decrease. Actually, that has been discarded. But as I'll discuss shortly, there is another aspect to it. There is research which shows how different forms of drugs, how different drugs have shown results in different patients and whether infections are recurring. There are there is research which shows how different vaccines, uh, the prior vaccines that have been used, whether they have had any impact, possibly, because the number of COVID-19 cases varies from country to country, and some countries may have some form of vaccination and so on and so forth. So the point is this: when you look at those research papers, you realize that there is plenty of information which is related to COVID-19, which is uh, very helpful in getting better insights on this disease. And when you get better insights on the disease as to how the virus is spreading, what are the possible factors contributing to the spread of the virus, except of course human to human transmission, uh, and uh, what are the different therapies out there, when you consider all of those things, then you realize those factors are really really important. And there are other things as well, like for example, there are plenty of research papers which talk about the structure of molecules. So when the virus enters, of course they discuss about the process that takes place when the virus starts entering the body. So the molecules which the proteins and other molecules which come into contact, the structure of those molecules, how that structure plays a role in the infection. What if the structure were different? What if the structure were to be modified this way and that way? So it they of course discuss chemical reactions, but then it is not just a chemical reaction. So your these COVID-19 research papers also have references to drugs and molecules, but then they don't talk explicitly about the structure and how changing the structure of different uh, targets, say modifying pH through the help of certain chemicals, can actually help in preventing infection or can help in dealing with the infection better. So the very purpose for which knowledge graphs are built, that is to actually establish relationship between seemingly disconnected entities, seemingly unrelated entities, is not served here. Let me discuss this in more detail. So this was the first kind of limitation that you have. So the first kind of limitation is these knowledge graphs are actually not showing the relationships between all possible entities that are out there. Uh, there are actually thousands of them, lakhs of them. When you actually have a look at the research papers, you see that very clearly. The second limitation was that these knowledge graphs are actually kind of to an extent they are complementary. So one is good in visualization, one is good in to be in being able to retrieve the documents which have references to certain entities that you would like to do more research on. Uh, some of them are very interactive. So those are limitations of one knowledge graph which are actually not present in other knowledge graph. But however, there is a lack of interactivity in general. So you have knowledge graphs which are more interactive, but then as I'll show, I would want to have features which I would like to have a knowledge graph or representation which takes you into account everything. I mean, which has all the limitations of the current knowledge graphs addressed from the backend perspective and from the front end perspective, which has the best form of interactivity. So that is something that I'll come to when I'll discuss the knowledge graphs in greater detail. So coming back to my general limitations, as I mentioned, one of the limitations was that the relationships are limited to associated genes, proteins, drugs, and full strength of the research papers is not exploited. And let me take up specific examples here to make the point more forceful. So when you read the research papers, you find that there are plenty of them which focus on insights from different experiments, which focus on the impact of other variables. I mean, variables just different from just drugs and chemicals and molecules. And for example, what I refer here is a research paper, photobiomodulation, shining light on COVID-19. I'll not necessarily go to it, so these slides are shared. You can open that and read it for yourself. But basically, this research paper shows that light, or to be more precise, radiation in specific wavelengths, in visible and infrared wavelengths, can have uh, a positive impact in reducing the lethality of COVID-19. It can reduce the lethality of COVID-19. Now, this is an important observation, so which may not have necessarily been tested before. And when this result comes out, it is important for everybody to be aware that this is a possible strategy in dealing with COVID-19. There is research which shows how the spread of the virus in different countries, how the infections, how the death rates can be correlated to the immunization in those countries having to do with other vaccines as well. For example, there is research which shows how countries which have had prior immunization of BCG have shown a lower infection rate and death rate. But again, that doesn't establish a correlation. That doesn't establish a cause between BCG infections and lack of infections. Sorry, BCG vaccination and lack of infection uh, related to COVID-19. That may at best be a correlation. However, it is important to take all these insights into consideration, take the details of this research into consideration, and do an active analysis of it. So, while developing drugs and vaccines is important, it is also equally important to see whether those drugs and vaccines are being effective. Uh, it is important to look at all the cases where, even after treatment, the virus may be coming back, people may be getting reinfected. So the virus shows a recurrent presence. The research paper which I referred to here actually shows that the virus remanifested 4 times in that person after some days of illness. And I think that has consideration of these things is very important while developing vaccines. So one needs to include the specific details. One needs to integrate them as part of a larger whole while one tries to focus on development of drugs and vaccines. You have research which shows how different environmental factors are related to spread of the virus. For example, there is a paper which shows how ground levels of ozone, O3, are actually positively correlated with the spread of the virus, while ground levels of nitrogen oxide are negatively correlated with the spread of the virus. And this research was actually done in Italy. Uh, so there is similar research out there for different parts of the world, not necessarily for O3 and NO2, but for other environmental factors. Now, people were just starting to talk about, you heard a lot in the recent days that there is a possibility of airborne transmission of COVID-19. So people have started doing research on that also. So while every research may not have been, all research related to that may not have been fully validated, and people may not have necessarily come to a conclusion except for some very specific conditions. It is helpful to actually consolidate it as part of a universal graph so that people who want to actually refer to that kind of research and relate that to other possible entities should be able to do that. Uh, you have research which shows that how the virus behaves in different conditions, how body temperature and host species preferences of this virus, the causative virus SARS-CoV-2, are impacted by temperature. So this is not about that with temperature infections will reduce, so that has been disproved now. However, it has been seen that this virus, as regards its animal hosts, is seen to spread in those parts of the body where you have lower temperature. So even in the lungs, in the airways, there are, though the receptor, ACE2 receptor, is spread all over the lungs for some hosts, animal hosts, for example, in ferrets, it is seen that this virus manifests, this infects only the airways which are at a lower temperature. I think it impacts the uh, lower airways versus the upper airways. So perhaps the lower airways are at a lower temperature, and the upper airways are not impacted, and it could be vice versa. But whichever the airways are at lower temperature, I don't actually recall the content of the paper that precisely, they are impacted, and not the other one. It similarly shows that there are creatures which have a high mean body temperature than human beings. So there are organisms, there are animals which have lower mean body temperature. So it has been shown that the virus is able to actually replicate more easily. It is able to in fact have more infection in creatures which have a less body temperature than humans. And this impact of the virus is seen less in creatures and organisms and animal hosts which have higher mean body temperature than humans. So this paper actually discusses that thing in greater detail. And this coronavirus, this actually, though the source, the animal the set of animals, the animal hosts are not yet clear, but this is a zoonotic virus. It has emerged from animals, so there are animal hosts to this. It spreads from humans to humans, but the reservoir is still an animal. So if we do that kind of research and we have this kind of relationship, we'll be better able to go to the host of the virus, to the actual host of the virus. And while making vaccines and drugs is nevertheless important, unless we are able to locate the host of the virus and unless we are able to contain the host in some way, you never know whether you'll have the same host uh, being a reservoir for some other kind of virus. So you never know whether your virus will mutate or not, and then even your vaccine uh, may become ineffective. So the point is, uh, it is helpful to keep all these factors into consideration while making a knowledge graph. So a knowledge graph is really expected. The beauty of a knowledge graph is it shows you the relationship between different entities which are seemingly unconnected. Uh, of course, knowing relationships between drugs and chemicals uh, and diseases is very, very important. But we cannot miss out in other relationships, in which who knows actually will play a more dominant role in tackling COVID-19. For example, it may be difficult to develop a vaccine so soon. However, it may be easier to say focus on radiation therapy for COVID-19. So all this thing needs to be integrated together. Another major limitation of some of these knowledge graphs, not all, is that there is more focus on listing documents rather than discovering relationships between entities contained therein. So, for example, if I were to search for different aspects of, say, the drug remdesivir, which was touted as a prominent drug for, as a useful drug for tackling COVID-19, or any drug for that matter, hydrochloroquine, etc. Uh, what these graphs do, they refer to the research papers which actually have these terms in them. And while that is a very, very, very helpful exercise, but it is not something which a COVID graph is expected to do from the perspective of connecting entities. So what they are doing is they are actually connecting research papers with concepts. But I think COVID graphs are meant more to connect different concepts rather than the documents with concepts. So while this feature is helpful, but again, it misses out on the main requirement. So as I discussed shortly, it's the IBM COVID-19 knowledge graph, which does this. If you just want to search for any entity, where it is present, which papers it is present in, if you want to see which other entities are referred to in that paper, you'll be able to do it very well, very efficiently through the COVID-19 IBM COVID-19 knowledge graph. But then what it precisely lacks is it lacks the functionality of uh, showing the relationship between the different entities which are in those papers. I'll come to it as in maybe 2 or 3 slides. Another important limitation of these COVID-19 graphs is, at least for one of them, that they require good domain knowledge. For example, you have one COVID graph, which is the biological knowledge miner, biomedical knowledge miner, for which you require knowledge of BEL, which is biological expression language. And as I'll illustrate when I'll go through that slide, you will not be able to use the graph unless you have knowledge of BEL. And from my experience with BL, that's not at all intuitive. So the utility of those knowledge graphs is reduced. They can only be used by domain experts who actually, I mean, every domain expert may not necessarily have full knowledge of BL. He may also have to do a good amount of research. And what is more to the fact is every entity, every physical entity cannot possibly be represented in BL, in biological expression language. So as I said, you have thousands of different entities which are there in research papers, which have an impact, which are related directly or indirectly to COVID-19. Now, it's not that every entity will have a representation in BL. So you'll miss out. Not only is it is difficult to have those entities, to have the actual compounds names, because I mean, you would have to either Google for that, or you would be maintaining a repository of them. You would go to a repository which you are maintaining, and then you'll make use of that repository, or else you'll not have concepts which are representable in bell form. So that is another important limitation. Another big limitation of the existing knowledge graphs is they do not take into account the suggestions of several studies. So when you look at research papers, there are plenty of authors which suggest how their experiments, how the insights their experiments reveal can possibly help in coming up with solutions to COVID-19. Those insights can help in the development of drugs, or they can help in the development of vaccines. So those insights may provide other forms of treatment. So you don't have these knowledge graphs actually centered around those insights per se. So knowledge graphs may not be expected to be centered around those insights anyway. However, it is important to have those insights as an integral component of the knowledge graph. So you can have a category where you talk about possible strategy against COVID-19. And when people go to that category, they should be able to see what are the different possible strategies which researchers have suggested. For example, when I was going through the research papers on COVID-19, I found that I've listed down three observations, and these come from two research papers. So one of the research paper discussed that the spike protein head the protein head of the head of spike protein is actually has vulnerability. Its glycan shield has vulnerability, and what that vulnerability is. So when you look at the spike protein is quite extensively glaciated. So this glaciation actually thwarts the immune response of the host when the virus tries to enter the host. However, uh, there are regions of the spike protein where this glycan shield is more effectively present, as it covers that part much more extensively than other regions. So the head of the spike protein is a vulnerable part compared to the stalk and the middle portion, and it is actually less glaciated. And if you have to develop drug targets, those drug targets should actually make use of, if you have to develop solutions, those solutions should make use of the fact that this part is less glaciated. So it will, if you attack this part, it will not be able to thwart the immune system. The immune system response will not be thwarted. The glycan shield will not be able to thwart the immune system response because it's not there. So this kind of insight helps you in coming up with a possible solution to COVID-19. So the fact that the spike protein head is less glaciated than other regions of COVID-19, and it is this glycan shield, it is this glaciation, which actually thwarts the immune system response of host from host. And when this glaciation is not present, so the immune system of host will actually have an effective response against the virus. This understanding uh, can help one in coming up with better solutions to tackling this disease. Another insight was that you have this RNA binding protein NSP9, and this has a dimeric form. So if you Google for this dimerization, so dimerization is a reaction in which two molecules have the same compound react with one another to give the adduct. So it's kind of two molecules coming together, two molecules of the same compound coming together and giving a product. So this is what you have for in the structure of NSPN9. You have two similar molecules coming together and a dimerization occurs. And it is discussed that this dimerization is responsible for the viral infection. And if somehow this dimerization is avoided, is prevented, or at least its extent is prevented, this viral infection can also be stopped, can also be reduced to a great extent. So a disruption of dimerization in NSPN9 is a possible strategy. There was another helpful strategy which talked about the process by which certain proteases. So proteases are actually enzymes which I think break down proteins. Yes, these are enzymes which break down proteins and peptides. How these proteases, how these enzymes actually play a role in viral infection, what is the role, what is their stake as far as infection is concerned. And this research paper mentioned that if you modify the pH in the environment, or if you inhibit these proteases in some way, uh, you will be able to perhaps prevent the infection. So these will be these are potential drug targets. So agents which modify the pH or inhibit these proteases, TMPRSS2 and TMPRSS111D, these are potential drug targets for COVID-19. Now you see, everybody may not be aware of these insights, and it's not as if these research papers start with these insights. So it's not as if these are present as titles in those research papers. So your research paper may be discussing some other thing broadly, but these insights may be captured here and there as part of some other discussion, as part of some subsection. And it is helpful to have all these insights collated together, because uh, they need to be tested out for efficacy, for developing effective solutions against COVID-19. And unless you have all these strategies listed coherently, you'll not be able to test them out. So I believe knowledge, one of the essential components of a knowledge graph to tackle COVID-19 should be, it should be able to list out those uh, strategies which can be effective in dealing with COVID-19. So, as I discussed, there are 4 or 5 main limitations. One limitation is the subset of entities being considered is very less. And though there are many more entities to be considered, the other limitation is that the focus is more on listing documents rather than on connecting entities. The third limitation is you may require good domain knowledge. For example, you may require knowledge of VL. The fourth limitation is that these research papers are actually nowhere taking into account strategy. So there is not a single research paper in which you will find any node through which you can navigate and see for the different useful insights which can help in tackling COVID-19. So you will not have a node in any of the knowledge graphs which will give you this information. And the knowledge graph which I am proposing to build actually needs to address all these limitations together. And this is, by the way, this is an important limitation. So imagine if you were to have a knowledge graph which had a node in it, which node was centered around possible strategy against COVID-19, you would be able to get a treasure of information. Let me discuss the knowledge graphs in detail now. The knowledge graph which I found, one of the knowledge graphs which I found quite useful was the IBM COVID-19 graph. And let me take this up first. So as you see, this is part of IBM's deep search. It's a very impressive functionality. So this page loads knowledge graph of COVID-19 literature, and there are several options there. I'll go through each of these options one by one to quickly illustrate how this works. Let me first go to this option on view reports, where you actually have reports of drugs and genes. And what are those reports? These reports are about which drug you will be able to locate in which documents, which are articles which correspond to those drugs, which have those drugs mentioned in them. And they also have articles which refer to clinical trials for those drugs. So, for example, for remdesivir, you could go and search for these articles, and you have linked to those articles here. Similarly, you have the same information available for genes. If you were interested in, say, this gene, you would find some these many articles, and you'd also have a reference to the gene bank. So this entire information is pretty useful. Apart from that, you have a functionality whereby you can actually have disconnected information where any drug which appears in a paper which has a COVID-19 concept is referred to, and then the trials for that drug and the relevant articles and COVID data for the drug are actually linked. So it starts from articles that mention a COVID concept. You have articles which mention a COVID concept are filtered out first, and then drugs which are mentioned, those articles are extracted when they are listed out, and then you have articles in which those drugs are mentioned, and for each drug you have articles to find you have articles which refer to the associated trials for that drug, and you have a similar process for genes. And as I'll show you just now, this is actually a very small subset of the knowledge graph. This is just restricted to drug names and genes. However, there is a larger functionality in this IBM COVID-19 knowledge graph, which actually implements the same thing for any possible entity. There's a list of entities out there which I'll shortly show, and you can have this relationship for any entity. However, it is helpful for us to realize here that what this is effectively doing, it is giving you a relationship between the document and the drug name, and then the document and the clinical trial for a respective drug. So it's like if you want to know which drug is talked about in which document, you'll be able to know that. If you know that, if you want to know in which document there is information on clinical trial of a particular drug, you'll be able to get that information from here. But it is still way different from actually connecting information on different drugs, from actually being able to see whether there are different drugs which have the same possible impact as regards a particular feature. If one of them has a side effect to other drugs which have the same possible impact, the positive impact, can they be used, and so on. So that is not addressed here, and I think is a major limitation. Let me go back and take you to the graph. So again, there are three additional features besides the knowledge graph, and I'll go through those three additional features also for sake of comprehensiveness, so that I don't miss out anything. This is a feature whereby you can actually search for a term. You can input a term and search for the papers which have that term present in them. So here the term was virus, and you have references to papers where that term is present. So these are showing which are the paragraphs which have that term. So say if I were to search for say again remdesivir, I would get documents which have references to remdesivir. It could be anything. I mean, it could be, so you have those documents coming up. It could be something like spike protein. Spike protein is central in COVID-19 infection. So you have references to spike protein here. So this is a very helpful feature. You wanted to locate where a term was present, in which research papers a term was present, you should be able to locate it from here. So they just have given a description of how they were able to do it. They are mentioning that the terms which we enter below are matched to nodes in the knowledge graph, from which we traverse to the paragraph nodes that are shown as search output. Again, this will be more explicit when I'll go to the knowledge graph itself. However, I'm sorry, I'll have to go back to yes, this was a link. There are two more features which I'll discuss, which I'll present. So this is a feature which is very specific to incubation period. If you actually want to know more information on different aspects of incubation period, you'll just type this thing. So for example, if you wanted to know the duration of incubation period, you would type duration, it would do this. If you wanted to know the say impact of the incubation period, or there could be a more meaningful search, I'm just entering impact. So what it's likely to do, it's likely to retrieve those articles, those paragraphs which have both impact and incubation period mentioned in them. So yes, so it just it did the same. So here you have lockdown's positive impact. So this may not be related to incubation per se, but then you have the same term occurring there. What could be a more meaningful search related to incubation period or number of days? Number of days. For how many days this incubation period should continue? Correct. So again, it has found documents, paragraphs which just have the word number. It's not necessarily number of days here, but even the number thing is helpful. Oh, you have number of days as well. But then wherein is the number of days of the epidemic? This is not related to incubation period per se. So this is a useful feature. I do not know why they just had a separate kind of module just for incubation period, but I believe they would have a good reason for having that. This is co-location of X and Y is a more generic feature where you just enter two concepts. So suppose you want to see documents which have reference to both remdesivir and say chloroquine. This is another drug which was initially tested for its effectiveness against COVID-19. So basically it will load the documents. Oh, invalid attempt to spread non-retrievable instance. What is this? Invalid attempt to spread non-retrievable instance. I don't understand it. I'll try with a different thing. Maybe I'll try something which has COVID-19 and remdesivir in it. There should be a generic search. Maybe I got the spelling of chloroquine wrong. Again, invalid attempt to spread non-retrievable instance. Well, let me try something different. I think I tried it a couple of days before. Enter X, enter Y. So let it be spike protein. So this co-locate expressions X and Y and they're containing paragraphs and articles. This should be general. Spike protein and then COVID-19. Good, it worked. So you have these articles where there is a reference to both spike protein and to COVID-19, but I'm not very sure whether it's working that way completely. Oh yes, sure. So they didn't actually highlight the spike thing here. Only COVID-19 was highlighted. So you have articles which have a reference to both COVID-19 and to spike, and so on. You have the second paragraph here. You have both spike and COVID-19. Say if I were just to know, I don't know why it wasn't working the first instance, but let me again check for remdesivir. I'm sure, of course, you have articles which contain both COVID-19 and remdesivir, both these terms. So this is kind of unhelpful because I think there is of course, there is a relationship between these two terms. So I would expect this relationship, this correlationship, to be shown there. Let me just try with one another example. Suppose I were to see the relationship between, what do you have? You have drugs, you have genes. Suppose I want to see the relationship between this enzyme, which actually plays a dominant role in viral infection. So this enzyme receptor, it actually connects to the spike protein connects to this enzyme inside the body of the organism. And I hope to see positive results on this. I don't know why it's not giving results on remdesivir. Yes, so there are references to this, both COVID-19 and EC2. Sorry, COVID-19 and yes. So this is working as expected. Now finally, I go to the most powerful feature of this knowledge graph, of this IBM's functionality, which is not actually these individual pages, but which is the knowledge graph itself. And before I do that, I'll actually walk you through the topology of this knowledge graph. So this knowledge graph has nodes which are divided into certain categories. So for example, you have nodes which are related to SARS-CoV-2 concepts, nodes related to COVID-19 trial drugs, to genes or genomes, gene or genome, to biologically active substances, to COVID-19 data, to region, to molecular function, pharmacologic substance. You have these paragraph notes. So paragraph notes are essentially those notes where you have information related to documents or to paragraphs, but of course paragraphs, where all these terms are occurring. So when you go to a paragraph node, you see actually those paragraphs in which terms contained within each of these nodes are present. So if I were to search about, say, the drug remdesivir, I would go to this node, I would select a drug from there, and then I would go to paragraph node, and then I would be able to see the paragraphs which have that drug mentioned in that. I'll do that, I'll display that shortly. You have these paragraph nodes connected to country, gene accession, assembly accession, and all these are internally connected. All these are connected to another central node, which is the gene bank. Similarly, you have the paragraph nodes connected to another set of nodes. One is centered around drug bank. So the CAS number, patents, packages, drug interactions, all of this information is linked just to one node that is linked to drug bank. So that's to say that if in case you wanted to search the information for, say, drug bank ID or drug interaction, you would have to go through the drug bank only. So for this node, you will not see any other relationship uh, except the drug bank, any other direct relationship except the drug bank. So you can move from this node to this node, and then you can move to other nodes. However, there are plenty of nodes for which there is a direct relationship. So for example, you have this node like drug product, which is directly connected to exclusion criteria, connected to outcome. This is connected to paragraphs also. Drug product connected to paragraphs. So there are nodes which are just connected to one other node, and there are nodes which are connected to multiple nodes. So if you have nodes which are directly connected to other nodes, you'll be able to see more extensive information, more extensive direct information. Otherwise, you'll have to navigate through other nodes. So this navigation is an overhead which you might like to avoid. There's a very important element here, which is one of clinical trials. So clinical trials associated with particular drugs, of course. The intervention model, the source register, study location, study binding location, intervention groups, exclusion criteria, drug names, word cloud, inclusion criteria, and so on. Well, I spoke everything. There's just intervention and trial ID then. The main idea here is, from this knowledge graph, you will be able to search anything which falls within this specific category. And so there is information on genes and various attributes of this information. So the gene bank locus, the organism, the gene bank assembly, the gene accession, the country where I believe where this gene bank base is sourced from, the EC number, and so on. And you have information regarding the disease, the risk factors, the immunology factor, activity, etc. But as I'll show you, the downside to it is, though it is pretty extensive, however, this information this graph only shows you the paragraphs which have this information and doesn't actually capture the relationship between any two entities directly. I'll come to it in a short while. Before that, I'd like to show you that all these nodes that they are referring to are actually the total number of nodes which you have is 1342828, and so these are actually node categories, which within each of those node categories you have further nodes. So for example, within COVID-19 drugs, you have names of drugs: hydroxychloroquine, chloroquine, remdesivir, letonavir, etc., etc. And the total number of nodes is in this is this number as of now, and I believe they may be updating it. And this is a various category. These are the various categories. So drug interactions, names, products, drug bank ID, V5 exclusion criteria. These are things which I believe you would be seeing here more or less. Maybe there are one or two which are not explicitly mentioned, but they would be a part of the knowledge graph nevertheless. So you have P and other things. Now you have the edges. So these nodes will be connected through edges. There will be various combinations of edges. So there are plenty of edges. So you see, when the number of nodes is close to uh, 1 million, the number of edges is bound to be larger, and you have 17 million edges. And because I believe there would be more than just one relationship between two nodes. So one node will be connected to multiple nodes, and you see, these are not just uh, these nodes. You actually are referring to the nodes inside these nodes. So there will be multiple connections. Uh, so drug bank to article reference, drug bank to CAS number, and so on. So this seems very powerful. And initially, when I looked at it, this was quite impressive, and so you would be impressed. You might be asking me the question, isn't it a knowledge graph which is sufficient? What more do you want? And my answer to it is again twofold. And one, I had 4 points initially mentioned. One of the important points was, uh, which I mentioned in reference to IBM, that this is more of a document searcher than a relationship searcher. For example, let me go to it anyway. Now, let me go to the search option, and the search here goes two ways. So they have some prepared workflows. For example, they have some questions, a limited set of questions for which they have prepared the workflow as in, if you wanted to see any of these questions, does temperature and humidity affect transmission? What will happen is you will be directed to the paragraph notes for those questions. So paragraph notes are essentially notes which contain information on paragraphs which have relevant terms mentioned. So this is akin to your search functionality that I described, that I just uh, tried a couple of minutes ago. So say if I select this paragraph node, all right, and then I just click here, as in data belonging to this node. So this would have temperature and humidity mentioned there. Yes, temperature is mentioned, and so should be humidity. Well, humidity is not mentioned, perhaps because only temperature was mentioned, so they took up temperature. So there might be another article where you have humidity as well mentioned. So say if I were to take this article, uh, if I were to go to this, here again I don't have humidity. There should be some article in which I have reference to humidity. Or in case they don't actually have it, that's a bad thing, because it's talking about both humidity and temperature. I close this. I just want to ensure that it's a fresh search. Yes. Even this doesn't have it. There is just one location. I'll try this now. Oh, fortunately, you got one after 3 or 4 trials. So this is an article which has information on humidity, and this has information on temperature. Should have information on temperature. Yes, it does have. So this is an article in which you have information on both humidity and temperature, and one should be able to read it and see the relationship. But you see, though it is quite helpful, but it doesn't actually do what a knowledge graph is expected to do. So you actually have to go through this paragraph by yourself, and you have to understand how this temperature, how this transmission is affected by temperature. So if you had a knowledge graph, it simply showed you that temperature has no impact on transmission. So the node between temperature, the vertex, the edge between temperature and transmission nodes simply showed the relationship has no impact. That would have been more useful. So uh, while when I discussed earlier that these knowledge graphs are actually showing a limited subset of entities, one may think in this context that no, it's also talking about temperature. Well, partially right. But the point here is these are some very limited workflows which they have prepared. So you again don't have all questions here. For example, you don't have questions related to how, say, light impact coronavirus, how it impacts the how it can be used in different therapies. And again, even when you have those questions, even if you had those questions, having them would still not be quite useful, because it would simply throw references to articles which have those things mentioned, and you can simply Google them as well. So I don't think you require a knowledge. You require a knowledge graph exclusively for it. I think even Google, when you Google up something, it does it through knowledge graphs. But what I mean to say that a knowledge graph is a much more powerful feature than just doing that. Uh, so these were some prepared workflows. Let me now come to the main thing. I discussed the graph structure here, is it not? And I'll now actually take one category, COVID-19 trial drugs. So I'll go to COVID-19 trial drugs. This is a node category. And what this displays is all the drugs, possibly all the drugs which are under trial for COVID-19. And I'm generally inclined to searching about remdesivir. So this was actually touted by uh, Trump as one of the most effective drugs. And there was a discussion in India also, maybe some weeks before on this. I think this is now available in India too. However, the price may not be that low. Nevertheless, so I found quite many references to it, and this comes to me first when I so this and hydrochloroquine come to me first. Hydroxychloroquine come to me first when I think about COVID-19 drugs. So you, you have reference to remdesivir, and you see the other things which you are getting are you have these questions, prepared workflows, and then you have paragraphs. So if let me open this link in another tab. Why go back and forth every time? So when you look at the COVID-19 trial drug, you see it is connected to paragraphs. So, and it's not connected to other things like say gene bank or to say a drug bank or to clinical trials. That's why in this, you only see paragraphs mentioned there. Had it been some other category which was connected to more nodes, you would have seen other nodes as well specified here. So if I just click on this will show me the paragraph nodes which are connected to remdesivir. And suppose, well, I choose as I did for temperature and humidity. Suppose I choose this paragraph node, and this should show me the paragraph which has data related to remdesivir. So this GS5734 is I would say this is the biological name for remdesivir. So you have, well, they just have reference to GS 5734 maybe for in this document. But I am still impressed because you see, uh, they internally correlate that this remdesivir refers to GS 5734. However, to better illustrate it, let me take another paragraph node and check its data. Oh, it doesn't even have that, seriously. Rem, remdesivir, oh, it has. Oh, I'm so sorry. It doesn't. Let me make it small. Whether the search is impacted by that. No. I don't know why it doesn't have it, but it's expected to have it. So if you were to, there should be something, maybe it again has a reference to GS. So GS was something which I found, yes. So it has a reference to GS, 5734. So not a direct reference to the word remdesivir, but you have reference to GS 5734. And say, just one last time, I take another node, which is this, and I check for reference to remdesivir, which comes very clearly. Now, these are actually articles. These are paragraphs which have information on remdesivir, and uh, to be able to get these paragraphs is helpful. Further, if, for example, you were not just interested in paragraphs on remdesivir, you wanted to see other information contained in those paragraphs. Suppose you wanted to see the chemicals, the paragraphs which have information on remdesivir and which have organic chemicals mentioned in them. So, well, remdesivir, it shows up remdesivir as organic chemical. Let me refresh it. Hold on. I'll actually redo the search once again just to get it right. So you have paragraph nodes, and you have this paragraph node. I actually want to see the organic chemicals which are associated with this. Yes. So I don't know why they call small molecule an organic chemical, but this is what you have in these nodes. So these organic chemicals are being referred to in this paragraph node, which has reference to remdesivir. If I just add a new paragraph node, you have more chemicals coming in, organic chemicals coming in. So of course, if I just deselect them, so you have just the, okay, so remdesivir is considered both as an organic chemical and a drug. That's fine. That was my mistake initially. So what you see here is the organic chemicals which are mentioned in these paragraph notes. So if I just take this, you have this organic chemical polysaccharide K mentioned in this paragraph note, and this paragraph note also is linked to remdesivir. So this topology where you have uh, information on what is connected. So you have COVID-19 trial drugs connected to paragraphs. Then you have organic chemicals connected to paragraphs again. So you can traverse from COVID-19 trial drug to paragraph. From paragraph, you can traverse to organic chemical, or you could traverse to pharmacologic substance. So this is something which can be explored in this knowledge graph. However, you would see that while this information is helpful, I mean, you could keep dragging it down to the level you want. But so again, you have, so uh, this is further connected to paragraphs. Organic chemical is further connected to paragraphs because this is just one reference that connects only to paragraphs directly, and then from paragraphs you'll have to go to something other different, same amino acid, peptide, or protein. However, uh, if you were to choose any other question here and say percentage of asymptomatic infected people, so see, it clearly gives you the paragraph notes which are related to that percentage of infected people. Now these paragraph notes, if I search for any of them, let me see whether they have reference to polysaccharide, sorry, polysaccharide there. No, so they don't have a reference to polysaccharide here. So seems that these paragraph notes are just those notes which are result of this question. So they don't actually refer to polysaccharide. Even if they were to refer to it, you still have a limitation. You see, so what this knowledge graph is actually doing, it is showing you the relationships between entities and the documents which those entities are present in. It is actually not showing you the relationship between different entities. So it doesn't show you the relationship, for example, between remdesivir and say hydrochloroquine, or remdesivir and letonavir. So suppose you wanted to know how whether hydrochloroquine and remdesivir share some common features. So for that, the best that you can do is actually you can go to paragraph notes. Maybe these are paragraphs which specify both. Uh, so this I'll have to disable this last thing because this is coming up every time. Uh, Both hydroxychloroquine and remdesivir. Well, this doesn't. So maybe it just specifies, maybe it the functionality is that way that when you choose multiple of these, so even if only one of them is present in a paragraph note, it displays that also, I believe. So you have remdesivir here. So however, even if you had both terms here, it would be just like the co-locate functionality which was demonstrated earlier, and you don't have a way of knowing whether hydroxychloroquine and remdesivir share the same, share some same features, whether they have similar kind of impact, whether they have similar side effects, etc. That information is something which you'll actually have to collect from your end only. So you'll have to go to the relevant paragraph and you'll have to do it for all paragraphs, and then you'll have to collect that information. Now, this is this functionality is helpful, but this is not what a knowledge graph is expected to be for. So this is a major limitation of the IBM knowledge graph or the IBM corpus processing service. They still call it a knowledge graph. So if you were to Google for IBM knowledge graph, COVID-19 knowledge graph. Well, let me Google for it rather than going to that link per se. Yes. So they are referring to it as a knowledge graph, COVID-19 deep search, COVID-19 IBM research. So this can be ingested into a knowledge graph as a structure that allows users to explore the latest published research. So this is limited to just exploring the latest public research, and this knowledge graph is not actually aimed at showing the relationship with entities. So suppose I just wanted to know the relationship between any entity X and any entity Y. All this would do is it could point me to articles where both entities are mentioned, but so by using, for example, the co-location feature, but it can possibly not show me a direct node which shows how those entities are linked. So this is one important limitation of this uh, IBM COVID-19 knowledge graph, which actually, to a great extent, to be frank about it, makes it uh, not so useful. So this is something which you can as well Google about. So if you wanted to have research papers where COVID-19 is remdesivir, for example, is being referred to, you could just Google about it. So you could do is you would go to Semantic Scholar. You have this COVID-19 Semantic Scholar, which is exclusively meant for research papers having to do with COVID-19 research. I believe this is, how does it open? This is PDF Semantic Scholar for, so the way you have Google Scholar, you have a COVID-19 Scholar also. Maybe this one. So you should be able to go here and search for information related to COVID-19. I think it was not the one which I was actually trying to refer. I saw another, so maybe this covidscholar.org. Yes, yes. So suppose you wanted to see information related to remdesivir. So these are the articles which show remdesivir, and you'd have to actually go through those articles by yourself. So this has been implemented by IBM. They call it an IBM deep search. And this is what is known as COVID Scholar. So I would just conclude the IBM discussion, but the IBM COVID knowledge graph discussion, by saying it's a powerful feature. So it enables you to actually see how certain elements are connected. Elements as in they are connected in the literature. So there you would be able to find papers which have references to both an organic chemical and a particular drug, or the relationships of other relationships having to do with different nodes. But at the end of the day, it boils down to paragraphs where you would be able to just see the information uh, contained in paragraphs. You would have to go through the paragraphs by yourself, and I believe knowledge graphs can do much more than that. Now I come to the next knowledge graph, which was this COVID-19 Graph Explorer, and this is one of the best knowledge graphs I've seen. And let's investigate this now. So let me open this. So I call this my favorite knowledge graph because the visualization, as you will see, is quite appealing. I mean, not this one, but as I'll drill down further into it. So this knowledge graph is powerful in the sense it actually shows relationship between different entities. It is what I call a real knowledge graph. For example, suppose you are interested in knowing about uh, first papers which have to do with publications which have to do with SARS. This is akin to the IBM functionality, but I'll start from there. So it gives you the articles which have to do with SARS, and hold on. So the number of those articles would be pretty huge. I think they are just displaying a limit of 10 there. And what happened here? Let me try that once again. I think I clicked some wrong tab. Let me actually move it to the other side. Taskbar settings. Bottom right. Correct. So this wasn't displayed there actually. So I suppose I want to just limit it to 5. I would get the option there. Yes, the load all option had to be there. So I want to load the selected paper. So there is nothing new. This is what your IBM also gives you. However, if I want to see the genes which are contained in this paper, if I want to load that information related to genes, I'll be able to do it. And the way it does that, the visualization shows for that. So load more, I want to load genes. It is giving me the results of genes which are contained in this paper. I want to load all of them. So this loads all the genes which are contained in this. Suppose I'm just interested in this particular gene. I can load the tissues in which this gene is expressed. These are the names of tissues where this gene is expressed. I can load them all. So this will expand soon. There is some delay, but I like the functionality because it's not present in many other COVID-19 graphs, knowledge graphs. Yes. So these are the different tissues in which that gene is present. If I were to go into any specific tissue, and so sorry, this is still for that for this. If I were to say just click on this, and then want to see all the genes perhaps which are present in this tissue, whichever the tissue was, I could load them all, and then this shall expand further. Similarly, I could search for genes straight away. So an example like, well, some example of genes I would have to Google. I'll see BRCA1. Good name, BRCA. So where is that? It's here. BRCA1. All right, so it will show me results related to BRCA. I can load this particular gene, and then this will get loaded soon. Should get loaded soon. I think I entered it. Let me try it again. It shouldn't take this much of time. That's not helpful, but I'll try it again. BRCA1. BRCA1. I see. So this already gave the results. So these are different aspects related to this particular gene, and suppose I load them all. Was it showing that only? Actually, I'll load this at afresh because I'm not sure whether it's cache which is having an impact on this. So I'll take this to incognito first. Sure. So you have BRCA1 as the gene for which I'm willing to choose. I selected. No, so it was a kind of a catchy impact. Now for this gene, I want to see again the mentioned papers, the patents, the encoded proteins. For example, these are all the encoded proteins in this gene. And suppose I want to see in further information uh, all encoding genes which have this protein, or I wanted to see related entities. So well, these are names of persons. So maybe these persons were involved in discovery of this gene. Yes. And when you go to this person, it shows the own patents. Oh, let me try it once again. I'll So for this person, I want to load the own patents. So there are no patents for him. Okay. Maybe for this person, no patents for him as well. I'll just load selected. Maybe this is the name of a patent. Oh, no, this is not the name. I don't think it's displaying the patent information properly. Nevertheless, so what I wanted to show you was that you have this feature in this Graph Explorer whereby you could search for some specific categories. You could search for patents, publications, authors, affiliations, genes, and proteins, and maybe more. Yes, you can search for entities, diseases, pathways, and tissues. Let me show it what it shows up in entities. And maybe I'll enter, what should I enter? Maybe I'll enter remdesivir here. Remdesivir. Something went wrong. I didn't find it as an entity. Okay, I'll enter ACE2. Is the entire thing not functioning, or BRCA1? So those were not actually recognized as entities. I'm not sure what it actually means by entities then. So because I thought I should be able to search for some general information here. Suppose I mention something like spike protein. Well, this should be in proteins only, spike protein, but so you have drug name, you have spike protein, you have what else? So I could mention, say, NSP9. This is another RNA binding protein, but wanted to see how it displays. It's not displaying, so this is kind of useless and not helpful. So it shows it has names of different diseases. It can of course your disease which is under consideration is COVID-19. So I'll search for it, and well, this is poor. This is poor. So if it seems I'll have to reload it every time. Refresh. So where was I? I was on diseases, and I was on COVID-19. Correct. You have this disease, and then you have the associated genes along with this disease mentioned here. Well, this is pretty slow. Not sure why. Don't think it has to do directly with my internet, but what's the speed here? It's not that bad. I mean, this is fine. So this is not working well. I mean, these are all, this will count as another limitation of this. So I had to refresh it. I just wanted to try one more thing. I wanted to see whether I could get something in the entities by refreshing it. and now I'll go to entity section. Suppose I wanted to search for remdesivir. Wanted to start from blank. Remdesivir. No, so it actually doesn't count these as entities. I'm not sure what these entities are, but certainly they are not drugs or other things of that kind. So when I started introducing this to you, I called it one of the best knowledge graphs that I've seen, and I would still say so. You see, and the reason for that is that this knowledge graph still gives you a functionality. I'm trying to search for publications having to do with remdesivir. How come? I tried for SARS earlier. For SARS, it shows me. All right. So as I showed you, you can go to any research paper which has reference to the information uh, which you want to see, and then there are different other related information. There is different information which is specified by uh, some names. It could be genes, it could be tissues, it could be diseases, which you should be able to load from there. And from each node, you should be further able to connect to other nodes. So one important limitation of this COVID-19 knowledge graph is, though it is very powerful, it is actually much more intuitive compared to the IBM knowledge graph, and it is actually it's a knowledge graph. So IBM, for example, doesn't display this information in this format. It doesn't actually show the links between genes and tissues directly. This does. There, you have to actually go through the articles. Uh, in this case, you don't necessarily have to go through the articles. So, for example, if you just wanted to search about a gene, you could just mention go to genes and mention that, and you would be able to further drill down based on the required options. However, the major limitation of this is there are two limitations. Point number one, the entities which they have here, all these are still limited. So you don't have any you don't have a feature where you'll have any possible entity, say temperature or light or maybe other gases. So something that I was mentioning earlier, things which are related to COVID-19, which may be indirectly related to COVID-19, and it will be helpful to see the relationships of these things with COVID-19 and other entities related to COVID-19. You will not be able to search for those things here. I thought you might find them in the entities, but then you see here, when you go for entities and you try to search for even something as basic as remdesivir, you don't find it there. So this is not helpful. So this does not contain information about all possible entities which may be there. There would be literally thousands of them, and they are a very integral, they should be a very integral part of your knowledge graph. The second limitation is, even for some entities which are present here, so this is talking about SARS gene, it talks about the tissues in which it is expressed, the pathways, the diseases, the papers, patents, proteins, and I can remove this item if I click on this. So these things are talked about, but then while these things are nevertheless important, you may have other relationships as well of this gene with some other entity, and those relationships are not captured. So while on the one hand it doesn't capture all possible entities, on the other hand it also does not capture all possible relationships of a given entity. So if you were to read more about this particular SARS gene, you would, of course, this gene has a particular structure, and if the SARS gene is causing a particular infection, if this is responsible for uh, if this is getting infected, if the organism is getting infected and this gene has a role there. So what is in the structure of that gene that plays that role? How can that structure actually be made use of in a different way to actually prevent the disease, to prevent infection? You would have research papers which would discuss about that information, but this information is not present here because this graph explorer gives you a limited functionality to search for specific categories. So let me summarize my observations on the COVID Graph Explorer now. COVID Graph Explorer is a very powerful tool as far as visualization is concerned. You can search for some limited number of entities, for genes, for publications, for patents. You could go to each of those entities And by choosing those, you could pinpoint your search to a more specific, say, research paper, or to a more specific gene. You could search for, so suppose you just search for SARS, it loaded all the research papers related to it. You could just search for a particular research paper there. You could go to that research paper, you could load the genes which are referred to in that research paper. You could go to one of those genes, you could connect other relationships. So that's a very, very, very powerful feature. And I believe scientists should be using it. They must be using it. This is very useful. However, the limitations are this doesn't have all possible entities. This doesn't cover all the possible entities. In fact, it covers a very small subset of entities uh, while displaying, while giving us options to choose from, both from the starting, and then it covers a very limited set of relationships for any given entity. So it will be very important to expand this knowledge graph to cover all the possible entities which are out there. And you see, sometimes when I tell people that we need to cover all possible entities, or as you're listening to it, you might think that those entities may be just too many in number. And will it be worth visualizing them? So the answer is yes, I mean, for two reasons. One is uh, you never know which information gives you the required insight. That's one reason. It's a very important reason. The second thing is visualization will not be a problem when you have an implementation like this. So in this implementation, you don't see everything together. At every level, you can drill down as per your requirement. So if I want to look at the load, if I want to load the express tissues, I can see whatever I want, and I can load information related to that tissue. And then with that tissue, I can actually see the information that I want. So it's not as if all nodes are displayed at the same time. The visualization can still be taken care of, but you need to have that information available with you. And I agree, it is not very easy to extract this information. In fact, what you see both in the IBM COVID-19 knowledge graph and in this knowledge graph, you have some very specific entities which are extracted. So uh, the way these knowledge graphs are working, they seem to be working on entity recognition, named entity recognition. If you remember, when I was discussing about the IBM COVID-19 knowledge graphs, uh, when I would click on a paragraph node and it would show the information related to that paragraph, you had you had rectangles around certain uh, words, and those rectangles were actually showing named entities. So uh, this is one of the biggest problem. In fact, it is also a challenge with creating a new universal COVID graph. That is something which I discuss in my next video. So it is easy to extract named entities. It is, however, difficult to extract general relationships uh, because the current NLP algorithms are not that efficient. So they are able to extract relationships, but then they may not necessarily be accurate, particularly in cases where you have a biologically dense research paper where the sentences may just be complex, they may have too many clauses, uh, and so on. So it is important to address those limitations. So it is first important to know what the merits of this COVID-19 knowledge graph is. It's important to make use of this knowledge graph for discovering insights as required. However, it is important to know how this knowledge graph can be further expanded, how the underlying information can be further expanded. And as I'll discuss in part 5 of this video, as one of the requirements in this initiative is I want curated data related to all possible kinds of relationships from the research papers. I also plan to share this. So while I'll build my own website, which should be similar to this because I find that this is an intuitive interface, I'll also have this information shared with these people who are behind this. So there is a research group of, I believe, 7 or 8 people who are behind this, who will actually love to have that information. So if this functionality is extended to include all possible relationships, I think this can go a long way in solving the problems uh, related to COVID-19. So this was a discussion on COVID-19 Graph Explorer. Now I come back to my knowledge graphs. I'll go to my third knowledge graph. We had this. No, it wasn't. It was a different tab. Yes. So now we move to Amazing COVID-19 knowledge graph. So this knowledge graph is also known as DRKG, Drug Repurposing Knowledge Graph. Let's discuss this. Okay, I'll move it back, no problem. So this knowledge graph is centered around a purpose, and the purpose is drug repurposing. And what that means is it possible to use any of the existing drugs against COVID-19? So, given the seriousness of the situation, the idea is, because we already know the side effects, we already know how different drugs impact people, the existing drugs impact people. It will be helpful if somehow we are able to see which of these drugs, existing drugs, will be more effective for people. And we can try with these existing drugs first. And meanwhile, more intensive drug development efforts and vaccine development efforts, new drug development efforts for development of new drugs and vaccines can go on in parallel. So what this does, this is unlike your other knowledge graphs like the IBM one and the COVID-19 Graph Explorer, where you actually see the relationships between different entities. What this does is repurposing, and for repurposing of drugs, it requires information on genes, on biological process, molecular function, pathway, compound, cellular component, tax, and not anatomy, disease, symptom, pharmacologic class, ATC, and ATC. So this information is taken in from different sources and is fed into their storage, and they have trained their models which make use of this information along with a logic which they are using, which I'll come to shortly. I don't understand that logic quite well, but then I'll show you what formula they have, some kind of formula which they are using. And based on that, for a given disease, for any given disease, they are trying to see which of these drugs is more suitable. So for example, they have these scripts which one can run. You can run these scripts in your own Python notebook. You can run them in Jupyter notebook, or in, say, you could do it in Google Colab. I tried doing that and I could produce the results. So let me try this COVID-19 drug repurposing IP, or this IPYND. So the Python notebook. So this is the objective here is to do drug repurposing via disease compound relations. And what they have is they have a list of diseases for which they actually want to find drugs. They would be interested in one of these diseases, which I believe should be passed as a parameter somewhere down. They look at the candidate drugs which have been known for all these diseases. So some of these diseases, so SARS-CoV-2 is a new disease, of course, but then there are other diseases which would be similar. And this is again a sample example. There would be other diseases for which there would be candidate drugs. There would be drugs and then there would be candidate drugs. So for SARS-CoV-2, you would have candidate drugs. They are maintaining a list of those candidate drugs, and they load their pre-trained model, which has entities and relationships. So these entities and relationships are as they are captured here. And based on these entities and relationships, and based on their model, they get embeddings. And finally, they have this score calculator. So this is what I was referring to, the formula, to the algorithm. And based on the score and further logic, they output proposed treatments for that specific disease. So for example, for some disease, they output these as a possible compounds with the score, and I think they selected then a few of them. 7 clinical drugs hit in top 100. So I think these are top 100 results, and out of these top 100 results, there are what they are saying is there are some of these drugs are already in clinical trials, and these are mentioning those drugs. Yes, these are 7. So the objective is drug repurposing. They have a logic of their own which they have implemented. They have a model trained on that data, and that data is coming from various sources. So information on drug bank, information on drug bank. So on compound disease engine comes from the drug bank. So on also comes from GNBR, and information on anatomy comes from HETONet, which if you are interested, HETONet is an integrative network of biomedical knowledge. So this knowledge graph has information taken in from different sources. There is a pre-trained model into which this information is fed, and some logic is applied to train that model. And once that model is trained, based on the new disease that you want to find a drug for, it gives you the relevant possible candidate drugs with certain score. And what they say is that they could find that these drugs are in clinical trials. So I would say this caters to a very specific requirement, which is drug repurposing. This is not generic. So I would, of course, like to point out that in terms of its effectiveness as regards fighting COVID-19 solutions is concerned, this is a very helpful implementation. This is very effective because they actually would have done a lot of analysis if they are able to get 7 drugs out of that list as already being in the clinical trials. This is a very, very powerful thing. However, I'm not sure whether one should really call it a knowledge graph. So this is more of an algorithm by which they are able to do drug repurposing. They still call it a knowledge graph, nevertheless, DRKJ, drug repurposing knowledge graph. And while the process that this would really help a long way, this would go a long way in uh, proposing better drugs for COVID-19, its utility as a knowledge graph is limited for many reasons. One of the reasons is you don't actually uh, you actually have a very limited set of entities which are being considered. So all those entities, all those generic entities which I've been talking about since the beginning of this video, they are not being considered here. And the other thing is you don't have an effective visualization for it. So of course you have code. I didn't find any, maybe I missed it, but in this repository I didn't find it. In case you were to find it, you could show it to me as well. I mean, I would do further research, but based on the amount of time I put into it, I didn't find one. So there is no UI into which one could go and just execute and see where the drugs, which are the drugs which are more helpful. So if they had that UI, that would be better. So I would conclude a discussion on this knowledge graph by saying that this is quite useful. However, this is not what a knowledge graph is expected to be. So a most general knowledge graph is expected to be, and it is important to critically expand the list of entities, because that will be the way we'll be able to discuss more, we'll be able to find more relationships. So while this is talking about drugs in particular, different experiments have shown how different factors impact COVID-19. It would be important to model those factors as well, both as part of the knowledge graph, and why not as part of their trained model also. So this actually is not linked to the knowledge graph, but all the information that is out there as regards impact of different parameters in COVID-19, the data from the entire world, from around the globe, can be actually taken up. It can be synced up and then presented to these people, and they can as well make their own modules, make their own models, which are trained on that data, and that will help us in getting better insights on COVID-19. But that's a separate requirement. So COVID graphs are required, knowledge graphs are required so that you can establish the relationship first. Stats based on actual data can always will always be helpful, but the basic relationship establishment is preliminary to that. So I now come to my next graph, which is known as biomedical knowledge miner. And like COVID Graph Explorer, this is another powerful knowledge graph out there. So it's not that straightforward to get this link from Google. So it's not, I don't think it's the top 2 or 3 links. So there is a paper related to it, which I found. And in that paper, this link was given. I went there and I found it to be a very useful graph. Let me open that. Let me open the graph. So I'll try to go to the dashboard. This has two useful things, two useful categories. One is the knowledge graph itself, and one is the query portion. I'll first go to the query portion to show you the features, and after that I'll go to the knowledge graph. Why I do that is once we see the query portion, we'll see a lot of different features which will actually make us accustomed to working with this biomedical knowledge miner, and from there we will be more easily go to the context of the knowledge graph. So before I start, a point which I like to make is this biomedical knowledge miner needs information in the form of BL, biological expression language. So all compounds, all processes, all molecules, all genes can't be referred to, can't be searched for using their names, using their English names. So there is uh, a representation known as BL, biological expression language, from which you'll have to actually get their corresponding names, and then you will be able to search for them. For example, let me start with this protein profiler. So this is the HGNC symbol. This comes as part of BL nevertheless. So this EC2 is a receptor. For EC2, the symbol is straightforward, but as I'll show you for other drugs, it is not that straightforward. And for other entities, here this is an enzyme. For other entities, it's not straightforward. So if in case you wanted to do a profiling of this, you wanted to see different information related to it, it lists everything. It lists the lyase name, it lists the gene identifier, gene groups. Of course, this is the SGNC identifier. It lists also, well, I don't understand what uniprot is, but it lists the function, and it lists in the actual knowledge graph how many nodes are those which actually are increased by this enzyme. So the entities represented in these nodes are increased by this enzyme. How many are increased by nodes? So there are 24 nodes which actually increase this protein. This enzyme have some positive or some increase in magnitude impact on this enzyme. However, this enzyme actually increases some other nodes, entities in other nodes in the network. There are 14 of such relationships which are actually increased by this. And so on, there is a relationship for decrease. Now, it doesn't actually specify which those relationships are. It would be more helpful. And there is a way you could go to the knowledge graph and see those relationships for yourself. But as I'll describe, there is big challenge with that as well. Uh, the other information which you have, so this was for a particular protein. Here you could pass your other proteins. So this is ACE21, of course. You may have NSP9 as other protein, and you could have the same search for multiple proteins. Also, this has only ACE2 because maybe it's not recognizing NSP9. What I did was I actually took some names a priori, and before uh, this presentation, I loaded some names from BL, and hopefully this should now load results. Yes. So this is an example of a receptor which for which they display the corresponding information. Now, and you would really need to know what those names are. And these names are actually different from the names you have for these entities in general. So for EC2, I would say ACE2, there is an exception, but otherwise, because you have the same name in literature, but for many of these BL names, the names are different in BL and in literature. Yes, no, you got it for this. Now, this helps, but however, you need to know the BL name, and even what you get is very limited information regarding the name, alias, gene group, and some other information which I frankly don't understand, but should be useful to people who work in this domain. Then you have another feature, which is this. I think this is a powerful tool. In fact, this is one thing which I like most about this biomedical knowledge miner. In this, if you mention any entity, say this is this EC2 receptor, you will be able to see how it is related to other entities. So presence of this receptor increases these reactants There is some I don't know what disinfection is. Maybe this is a process. So it increases that. It actually has an impact on viral entry into host cell. It has an impact on kidney diseases, and then they are talking about molecules or genes. It has impact on them. Further impact on brain ischemia, on obesity, etc., etc. So this is a very helpful feature because I didn't specify any relationship. I kept the relationship open. I kept the object open, and you should be able to see which it is possibly giving the relationships which come out there. But then the limitation is, even though it's powerful, there are two limitations, big limitations. One limitation is it's still limited to some very specific biological entities, which are actually genes, tissues, molecules, chemicals, drugs, etc. So the major limitation which is there in all knowledge graphs is obviously part of this knowledge graph as well. You can't actually find all possible entities that are out there. So you would not even have the BL name for all possible entities, for all physical variables. So you can't find it. The second thing is, uh, of course, if I didn't mention it just now, so this requires BL. So you don't know it, right? So you can't mention, for example, if you were to try and mention remdesivir here, and if you want to see all the relationships connected to it, you find no data. So uh, maybe if I go to remdesivir and I see its scientific name, remdesivir pronunciation, no. I want to go to the scientific name, remdesivir. So this is GS5734, as we were discussing earlier. Okay, GS5734. I search for this. It doesn't even show this to me. Now see, I do not know what the BL expression for remdesivir is, but even the scientific name, the name which is it is generally referred to, even in literature, except for remdesivir, is not shown up here. So, and then there is no question. If I were to search for general entities, say I were to search for something like temperature, impact on temperature as a subject, doesn't show up. I don't think it would show anything specific to radiation also. And for that matter, if I were to specify what else? So I specified if for E2 it works. If I were to specify any other entity uh, like maybe another drug, Obane, I'm using this name because I saw it being referred to in the research papers, in the research papers. So you don't have these. So this is a limitation. So I mean, whether you use it in subject or object, you don't have it in the database. You don't find it. So you actually need to have the BL names for it, and I don't think you can possibly have the BL names for all possible relationships out there. So somebody actually has to see what all relationships are contained in the research papers, and have to have the BL names for those relationships. So do you have a BL name for something like, for example, infrared radiation? Or do you have a BL name for something like uh, maybe something like a temperature, of course, or temperature is one entity, or the physical variables? Do you have BL name for? So I believe you should have BL names for chemicals like ozone and nitrogen oxide, but not for all of the physical variables out there which may have an impact on COVID-19 infections. So knowledge of BL is a prerequisite, and then it doesn't describe all entities. That's a major limitation. And as I'll show you, this is another feature. This is very limited data. So this was another impressive thing where I found that if I want to see the relationship between this and this from ECE2 to COVID-19, and if I wanted to get a graph for it, it would show me a graph. It would show me the nodes where you have a relationship between COVID-19 and ECE2. However, for some reason, it shows me only that and nothing else. So, this actually gives you a feature whereby you can actually vary the depths for yourself. But no matter what I enter, if I enter spike S protein, this should be directly connected to COVID-19, or maybe at best at two levels, at second level two. This doesn't show up. It shows up no entries. Even if I change the level here, or change the depth here first, no entries. Same here. No entries. It simply doesn't, well, let it load. Maybe it shows no entries. I never know. If I take a BL name, for example, I'm afraid it might go on endless execution. Fortunately, it showed no entries. Let me take a BL name and see whether it shows something here. I'll search for 121 first. Okay, I'll make it 323. The maximum depth range which it allows. So my inference is that this has limited data, and I think that is a kind of a solid inference because as I investigated it, this is based on manually curated data. In fact, like my thing. So there are a group of people who are involved in manually curating the data, and you see, as with manual curation takes time when you have a limited number of people working. In fact, this is the reason why uh, I'm reaching out to you all to help in manual curation, because these things are not easily extracted from the knowledge graphs. Sorry, from the research papers. The current algorithms are not foolproof, and for something like this, you need to get a foolproof corpus. Well, this doesn't load. Let it load. Let it take its own time. So I would tell you, no matter what I try here, I've tried several cases. For almost uh, any other case except for ECE2, I couldn't see a result here. Most of the times it showed no entries, even though I gave it information related to Bell entities. I presented the Bell entities here. And you would as well try it from your end and let me know in case I'm doing something wrong. However, I must like to add that I've tried changing varying the depths to different extents and tried different possible combinations: 1 1 1 2 1 3, 2 1 2 2 2 3, and so on for the third one. So I tried those combinations for plenty of different cases, but didn't find the results. And because they explicitly point out that they are doing it using manual curation, so I expect one of the reasons is limited availability of data. Now I come to something what they call as their knowledge graph, and uh, this is I would say the major part of it. But as I would show you, this is extremely unintuitive. For the same reason, you actually require good understanding of Bell to be able to use this. So the database which I'm interested in is COVID database. The user is COVID user, and the password is just COVID. COVID. By the way, the password information and user information is available here. It loads. So well, you can see here, this requires Bell. So let me start from the functions here. So when you search for functions, you see annotations: Bell by annotation, Bell by last author, Bell by PMID, and so on. So these all attributes, be they stats, be they namespace count, be they nodes, be they drug target, all those things. Uh, they have to be actually used from the Bell perspective. I mean, you can't enter information like just remdesivir. So as it shows, select distinct annotation as a notation from Bell relation. Now you have all these relationships maintained in the Bell format. If you look at its DB, It's still in function. Let me refresh it. Correct, correct. No, it shows. So it will reload again. It will reload. Well, it doesn't. Oh, it loads finally. So you see, what they show in their database are actually some elements, the names of which are kind of non-intuitive. So, you actually don't need to know about the DB to be able to make use of the graph. And this is an internal implementation. So possibly perhaps I shouldn't comment on that because you don't really care what the backend is like, but this is how they are maintaining. Fine. So when you go to browse, you would see that the kind of information which they provide, uh, the metadata, the annotation, the citation, is in a very specific format, and you could perhaps go to a particular document that you're interested in as per your requirement. Posio4, the document not found. This is just awesome. Let me try this. So here they are referring to some entities and to the journals in which journals and other research papers that they are present in, and you have references to those journals and research papers out there. Come on, this is also 404. So this is not working. This is another limitation. Coming to graph editor, again, because this is entirely based on BL, so you would need knowledge of BL here. Vertex edge panel. So you would first need to know how this interface is to be used, what the queries are to be written. So it's not a drag and drop interface the way you had in COVID Graph Explorer. And you also need to know the entities, the Bell entities. For example, when you had a look at the functions, you would know those actually are in terms of Bell entities. You would need those Bell entities, and between those entities, you can establish relationships. In fact, what they are driving here, well, this is not over. This is known as a Bell path. So this requires Bell relationships. So I would believe something like this to be shown there, but nevertheless, they do require Bell, which is not so intuitive. So, however, when you go to some other node, for example, and suppose you wanted to search for all the nodes related to this last author, you do get some quick results. Maybe I should refresh it once. You have knowledge graph, not knowledge graph, sorry, it was a distraction. So you have path, and there, suppose you go to last author. This gives fairly quick results, I believe. When I tried it last, at that time it was giving good results. Correct. So it is giving me the result of information which is related to this last author. So papers made by this last author, what is the graph of relationships in those papers. This is a powerful feature, but I mean, for this you'll actually have to know the author name. You'll have to just see the relationships. You'll just be able to see the relationships for the entities in that paper. However, the general idea is to be able to expand it, to expand a list of entities to cover all the possible entities that are out there and to make a consolidated knowledge graph. You could do the same thing for publication. Now, I don't know whether Springer.com or something should work here. Let me give it a try. No entries. So, all right. So you would require publications to be added in some other form, which is fine. However, even though last author and publication work, they are a very limited feature, and the biggest problem of this entire interface, be it the knowledge graph or be it this path or Balash or protein list info or protein profiler, is that they require domain expertise. Their use requires domain expertise in terms of the language, in terms of BL, which common people, or I mean, may not be, or maybe many researchers also may lack. So researchers come from different domains. There are researchers who are just investigating research on relationship of different vaccines, on relationship of different drugs having to do with COVID-19. They may just have entered the domain and they may not have full knowledge on BL. They may be researchers who are doing other kinds of experiments. For example, experiments on how COVID-19 spreads in different parts of the country, how does it spread by geography and so on, how physical factors like temperature, how different gases have an impact. These are the examples which I referred to earlier. They wouldn't be able to, those researchers would be coming from a different domain and they wouldn't have knowledge of it. So this knowledge graph is then utilizable only by a very small subset of people. And it actually doesn't show all the relationship between all possible entities. It restricts itself to a very specific set of relationships. This is what they mention in their introduction also. So if I were to go back here, they mention explicitly that well, oh, I see. So I'm so sorry. So they mentioned that they want to integrate as much relevant information to a single comprehensive model where users are able to investigate all known molecular interactions pertaining to SARS-CoV-2, yes, and possible therapeutic routes. So they contain information related to molecular interactions pertaining to this virus SARS-CoV-2, and not all possible relationships. So I believe this is having information on molecular interactions is quite important. It's kind of prerequisite to develop any drug, but then or to further research on drugs. But there are many more relationships which need to be captured, and this doesn't cover them. Finally, I move to the last one, and it is the BioGrecan COVID. This is another COVID-19 knowledge graph which I found, and so this graph was released recently, maybe 10 to 15 days before. This is kind of one of the latest graphs that you have there. I see. So this is actually a data science article towards data science article. Oh, I have already opened it. Yes, that's correct. So they do have an implementation for this, and they do talk about the connection details, but for some reason it's not working for my case. So let me show you what the problem is. When I actually go to my Windows and then I search for, let's use that, let me change it. That's complex. Sure. So if I search for graph gain, I need to connect to a database. I was just trying to demonstrate to you. So the challenge which I face here is, even though I connect, so this is the workspace which they asked us to download to try their biographic in COVID. However, when I do it, I actually face some error, and this is perhaps related to some version issue which I'm not being able to figure out. But nonetheless, I decided to go ahead with including it in the presentation because I can discuss the limitations thereof, advantages and limitations thereof, even by referring to the article directly. So they have a knowledge graph which is based on information related to proteins, genes, disease, gene associations, coronavirus proteins. Uh, well, these may be proteins in general, and these are coronavirus proteins in particular, protein expression, biological pathways, and drugs. And what they do is a standard thing. So they are trying to find possible treatments for COVID-19 by referring to this data set and the relationships therein. So when you know that when you have the relationship between genes, drugs, and molecules, this gene is impacted by this drug, or this disease is caused by such and such drug, and such drug is impacted by such and such chemical. When you have all those relationships captured, you're better able to find which of those drugs could be as well suited for COVID-19. So this is something which a major COVID-19 knowledge graph also does, and you can also find the same in COVID-19 Graph Explorer. So they also help you link the relationship between these very specific set of entities. They, as you can see in this interface, there are several nodes. This may not be that clear, but even if I expanded it, I'm not sure whether it gets expanded that way. No, because it's for the entire article. So, and I can't even maximize it. All right, but then even if I loaded it, would go to this level only. So these all are different nodes, and these nodes have to do actually with proteins and drugs and molecules, etc. And there are interrelationships between these. If I were just to show this to you, so some particular protein is linked to a particular virus, and it's linked to a particular drug, and that is also linked to a particular gene, which is they are talking about publication here, which publication this is present in, and based on this relationship, these relationships, they mention that they were able to find two important and interesting things. First thing which they were able to find was that this human protein, which is a component of the proteasome implicated in SARS-CoV-2 replication, uh, and they were able to find its encoding genes. So for example, by querying for the virus, we can find the associated human protein and a component of the proteasome. So the information which they have integrated is integrated in such a fashion that it makes it easier for them to query. However, the second important, so this is just this is a normal feature. The interesting thing was that they were able to identify a drug, carfilzomib, which is a known inhibitor of the proteasome, that could therefore be researched as a potential treatment for patients with COVID-19. So they saw that there is a drug. They found that there is a drug which is a known inhibitor of the proteasome. Which proteasome? This. So they were able to find that this is related to SARS-CoV-2, and they found that for this drug was a known proteasome. So they are suggesting that this drug can be used in the trials, as in this could be further analyzed for its efficacy against COVID-19. So this is the kind of a basic relationship which everybody who is working on knowledge graphs and around drugs, molecules, chemicals, uh, biological pathways, etc., tries to build. And this is the most basic thing about a knowledge graph. So this is quite useful. However, the challenge here is again the same. I believe there is good overlapping between this and the Knowledge Explorer, and in particular the Amazing COVID-19 knowledge graph, the drug repurposing knowledge graph, because they are focused on a specific set of entities, and their focus is on kind of drug repurposing, which is repurposing, which is fine, but then they share the same limitations. The limitation is the set of entities being listed to here, being referred to here, is very small. It's a very small subset, and you have thousands of other entities which may possibly which are certainly impacting COVID-19 as the research papers present. An additional thing is, this is not a limitation of this per se, but for some reason, when I downloaded it, I went to the relevant links and I tried to open it. It doesn't really connect. So I think I downloaded the right version. However, I do get an error. So even though they say that it should work, I'm not able to execute it. But most probably it should be a problem from my end, and I'll try and fix that. What would happen is if I am able to connect to this database successfully and run the query without any errors, I should be able to get results like this. So I should be able to execute something like this. What happens if I execute it right now? So the connection to the database is itself not that is not without errors, but I get TCP write field. No, I'm not sure why it's showing that. So is it a problem with the database connection or something different? And I'm not sure why it's even calling it a write, because the idea is here just to fetch information. So I don't have good knowledge on TCP. I don't have knowledge on TCP write. Nevertheless, I'll look at it from my end further. But I wanted to demonstrate to you. This is a new addition to the list of knowledge graphs. This is helpful, and the limitations are that this is restricted to a small subset of entities, and this doesn't have a good UI for it as of now. So the UI in terms of website. So and the client tool, this GraphAI AI doesn't actually work as expected. So there could be issues from mine, but that's for me to investigate as well. So fine, people, these were the 5 knowledge graphs which I wanted to refer to you. You could actually go through these links and inspect them in greater detail. So this is what I was hinting at since the beginning. We discussed 5 knowledge graphs, spent a good amount of time on them, and we found several limitations. There were some limitations which applied to all of them. There were limitations to which were specific to each knowledge graph. And then the idea is it not worthwhile to build a new knowledge graph which doesn't have these limitations? One of the limitations was linked to restricted number of entities which are present. That is the most important limitation. And in order to be able to resolve that, one would have to get the list of all possible entities and their relationships curated from individual research papers. And this is the main task for which I require your help. And I actually describe it further in next videos. Another important thing is that even when we have the data, we got to create a UI for that. We got to have an application which shows the data, which gives users the flexibility to interact with different nodes. And what I found from my experience, that a COVID Graph Explorer, where you had this template, sorry, this one. I found this is a good template. This can be made better as well. But so far from the knowledge graphs that I investigated, that's perhaps the best template. The issue is this is made by using Vue.js and HTML files, which I actually don't have knowledge on as of now. I'm trying to learn more about them, and I may as well require your help on that. So anybody who has any knowledge on Vue.js, Nudify, and HTML files, please get in touch with me. So it is with regards to this objective of creating a universal COVID-19 graph which fixes all the above issues that we plan to move ahead with other videos. And in the subsequent videos, I'll discuss what a universal knowledge graph is expected to be, what are the challenges of creating a universal knowledge graph. I'll illustrate to you my attempts made in that direction in terms of data curation and creation of knowledge graph based on the data. And then in the final video, I'll also discuss with you how you can help in this data curation. And of course, as I just said, I need help in the creation of UI as well. Hope you enjoyed it. I think this was kind of exhaustive. It was a bit long, certainly, but it was worth it. Thanks. Looking forward to meeting you in the next video.